Hello everyone. So as promised, I am back with the STL series, and in this video we are going to discuss about what vectors are. So as this is the first video, I'll give a brief introduction about the containers and iterators. So containers, if you guys are familiar with any working with any language, you will be familiar with containers. So basically when we need to store more number of elements, we need a container. Even if you're not aware of any libraries, I think everybody must have used an array or a linked list. So that is a container because we are storing more number of elements. And in C++, there are various containers like vector, stack, queue, map. So each container basically differs in the terms of functionality. For example, a stack is a first in, first out, or a queue is a LIFO form. So each of the container is designed so that it can cater to some of the functionalities. So it comes pretty handy when you are actually coding it. So this was the small introduction. I didn't want to make a separate video out of it because as and when we'll learn all these containers one by one, and at the end of the series we'll have the live coding session where I'll solve the STL problems. Then we will understand how these things work. And similarly, the iterators are nothing but kind of pointer. It's not exactly a pointer, but right now you can think of it as a pointer which is used to traverse the containers. So yeah, having to give that brief introduction, let's start with vectors. So if you're familiar with array, the vector is similar in terms of how the elements are stored, but then a question arises, why do I actually need the vector if array is already there? So if you are aware that array has the fixed number of size, suppose you have 1, 2, 3, 4, 5, right? So now what happens if we need to increase the size, or if we need to attach one more element to it? We cannot do it, right? If you try to attach it here, you cannot do it because array size is defined pre-hand. So to solve this problem, most of the languages have a kind of linked list kind of thing, right? So when this comes, you can dynamically allocate one more space. But the major problem with linked list is you cannot access any element in O of one time, because for example in array you can just do A of 3, right? And you can access the third element or the fourth element if you are taking 0 index begin. But you cannot do it in the case of linked list. So vector actually solves both of these problems. That means we can dynamically allocate the space. That means dynamically add the elements and also have a O of 1 access time. So this is like the most used container. Like I have for my interview prep and otherwise also I have done coding for like hundreds of questions, and the most most common container that I use is a vector. So this series will not just be teaching you STL, but teaching you how you can use it in competitive coding or to solve the problems. Because having solved all these problems, I know pretty much what functions and what containers are the most useful. Yeah, so having said that, let's jump into how you can use a vector. So before we get started, I will just tell you one thing, that whenever you are using a container, you need to add some libraries or headers, to be precise, in top of the code. So usually, like for example, if you are adding a vector, you need to add #include vector. For stack, you can add stack. For map, you can add map. But I'll give you a quick tip what I usually do, okay? So if you are taking notes, you can note it down. Otherwise, I'll add it in the link. So there is one library which is #include bits /stdc++.h. Okay, so this is the library that if you include, you will have everything, all the containers, iterators, algorithms. So as a coding practice, what I do, I don't add all the libraries separately, because I don't know what else I'm going to need while coding, right? So if you just add this one library, everything else is taken care of. So you can note it out somewhere. It is the most, beautiful header that you can add. Okay. Yes. So now let's jump into one functions that we see. Okay. I'll quickly erase this and then we can get started. Right. Okay. So whenever you are learning a container, what is the first step? How you will declare it, right? So I've already made a cheat sheet which I'll show you quickly. Okay. So yeah, I am actually preparing this cheat sheet as and when I'm preparing a video. So at the end of the series, I'll share this cheat sheet as well. So you don't have to come back every time you need to see, you need to revise. You can just quickly take a glance. So for declaring an empty vector, you just need to do vector and the brackets and type. So here I have used the example of integer, but if you want to make a vector or string, you can just type in here string or character. And yes, a vector can have only similar, like you cannot have integer at one position and string at one position. So the whole type of whole vector will be same. Okay, so this will create an empty vector. So what it will do is, for example, you gave this, right? So it will just create a placeholder. Okay, then if you want to define the size, okay, so you can do something like this. In the brackets, you can do 10. So initially what it will do is, initially it will create, suppose if I am creating a vector of size 5, so it will create a vector of size 5, but that doesn't mean it you cannot expand this vector. So that's the beauty of vectors. If you remember how we used to use stacks, we used to use arrays. If you have defined a vector of 5, array of 5, then you cannot add it, right? But what it will do is, it will initially create the empty vector of 5 spaces, and then suppose you fill this 1 2 3 4 5, right? And then again you want to insert it, you can insert here. Okay, so this is just the declaration step. Then other form of declaration is, what if you want to initialize it also? So what it'll do is, here you're creating a vector of size 10 and you're initializing it all with 0. So a lot of times, for example, if you want to have a boolean array, what you can do is, you can have a boolean array of say n numbers, n spaces, and you can initialize it to false. So anything is okay, right? Then what if you want to create an array of vectors? So if you see this second one and this one just have one thing different, the use of brackets. So here you are actually giving the size, but here what you are saying is, you need to create an array of 10 vector integers. Okay, so what it will do is, this is basically, you are creating an array that will have 10 vectors, and the vectors will be actually null or empty vectors. So don't worry if you're not getting it right now. I am going to code it, so it will be more familiar with you. Then another declaration. So another declaration is, you need to have a 2D vector. For example, if you're doing a map question, right, the adjacency matrix can be in a form of 2D vector. So I am telling you all these things because you'll kind of form an aptitude, like where this is exactly used. So most of the most used 2D vector I have used is in the adjacency matrix. So you just in the type, right, you can see here. So type can be anything. Type can also be some other container. So here in the type, you can give another vector of integers. Okay, and then the name. So all the initializations that I gave here can be applied here as well. For example, here I have combined the initialization where I am giving the size and I am actually giving it a default value. So n, that means n rows, then you will have a column of m, and you're filling everything with -1. So I will share this cheat sheet with you so you can actually try it out as well. Okay, so we already saw the how it is initialized, right? So I'll tell you few internal things that are very basic and that are used a lot. Okay, So first of all, the size, right? If you need to find, for example, you have a vector, okay, which have three places, 1, 2 and 3, and if you find the size, so this is a function that is used for the size, so it will return 3, right? Now comes the main part. What if you want to push or you want to add some elements? So here you can see that there are only 3 places. Now if I say, so for adding the element at the last, you need push back. Okay, so what I'll do is v dot push back, and suppose I want to add 4. So now here it will come and it will see, okay, now my vector is full. What do I do? So instead of just adding one place, what it'll do is whatever the current size of vector is, it'll double it. So it'll create a new vector with size 6. 1, 2, 3, 4, 5 and 6. 1, 2, 3, and here it'll push back 4. Okay. So now if you call the size function, it will return 1, 2, 3, 4, whatever the elements are filled. But we have one more function, that is capacity. Okay. So if you call this, it will actually return 6. So capacity and size differs. Size gives you whatever the elements are filled, and capacity gives you what the current capacity of the vector is. So all these things happens automatically, so you don't need to take care of anything else. Even if the vector is full, it will accommodate your request. Okay. Another useful function that we can use is v dot shrink to fit. So v is nothing but the vector name, right? So for example, now you know that you are done with the vector operations and you don't need to do any more operations, but you still have some spaces that are redundant, right? So what you can do is you can call this function and it will basically remove the extra spaces. So now after that, if you call size and capacity, it will turn out to be the same. Okay. Now we already talked about pushback, right? This just inserts one element at the last. So similarly, we also have a pop back function that does nothing but removing the last element. Okay. So let me clear this out and then we'll see some more functions. So this is the list of most common functions that we get with vector. So let's go one by one. Let's come to iterators first. Okay. So iterator is nothing but a way to traverse the any container, right? So if you do v dot begin, it will return your position of the first element. If you do v dot end, it will basically return the position of after the last element. So in this case, there was a position, but even if this was still here, return some position after that. Then v dot r begin, it is the reverse traversal, so it will return from the last position. And similarly, r dot end will do something like that. So if you want to traverse in the reverse order, you can use r dot begin and r end, right? Then comes the size function. So we already talked in brief about this, right? Size will return the number of elements. Capacity will return the total capacity that the vector is having right now. v dot empty will return true or false if the vector is empty or if the vector is not empty. Okay. Then we come to insert function. How will you basically insert a variable? We already talked about pushback, right? It will just insert at the last. But what if you want to insert at a specific position? Okay. So insert is a function that will take the iterator position and then insert this element at that iterator position. So if you do v dot begin plus 3, suppose, so this is v dot begin, right? If you go to third position, 1, 2 and 3, so it will come somewhere here. So here it will insert 7. So if there were some elements after that as well, it will insert at that position. It will not override but insert at that position. So this comes in pretty handy in most of the cases where you want to insert at a specific position, or for example, if you want to always insert the element coming at the front, then you can just simply do v dot begin and whatever the element is, right? So now let's come to delete. So similarly, if you want to delete the last one, you can just do a pop back, so it will delete the last element. Then you have a function called erase. So it works in two ways. Either you can give a specific position, so that way it will just delete one element. For example, here I've taken the example of where I'm deleting the first element. So here I'm giving v dot begin. You can also give it like v dot begin plus 4, so it will delete the fourth element. But what if you want to erase the range or a subset of that vector? So you can give the start iterator and the end iterator. So here it will delete the whole vector basically. So in this way you can delete more than one elements. Then we have v dot clear. So v dot clear deletes the whole vector. So for example, if you have a vector of 6 positions, so it will just empty the vector. So if after that you will do a size, it will give you 0. Then we also have some functions that might come handy. One is the swap. That means you just swap the elements of two vectors. So if you have two vectors v1 and v2, you can use this to swap the two vectors. Then at some points you also need to check whether two vectors are equal or not. So you can just simply use double equal to operator. So this returns a boolean true or false. You also have not equal to in the same way. I also forgot to mention you have something called v dot front. So it will return you the first element, and v dot back. So it will return you the back element. Okay. So yeah, this is pretty much it. And yeah, if you need to get the element, what you'll do is you can just simply get the element as you get in the array. So this will get you the third element. You can or the third index element. You can also do v dot add 3. So these things do the pretty much same thing. And for traversal, it is also same as the array. So here you can just use v dot size function to get the size, and you can have a loop and just print it out. So this was the introduction where I have given all the functions that you are used. Watch the part 2 if you want to see them in action. I'll code it and I'll show you the output for each of the things. If you have any query, just link down below, and if you want the cheat sheet, I will give that at the end of the series. So it will basically have all the things that I have taught. So that will be your reference. If you like this video, give a thumbs up and subscribe. Bye bye. Have a nice day.